Good day guys, my name is Madera from ECE23 and I'm here to present to you about the performance task number 8 entitled modularization and coding technique. Here we will tackle about how to compute for entropy using Shannon's entropy equations. First, we will use our first name and last name as an individual reference. So my name is Nico Madera and we will arrange this in an alphabetical order and combine the similar letters, so we end up with 7 letters, and the 7 letters is A, C, D, E, I, M, and O, R. Based on the resulting letters or symbols, determine the following. First, design two different binary machines. Find the probability of occurrence of each letter based on your binary machine. Compute for entropy. Use probability method. Use Hartley equation or Hartley function. Compare the results on a summary and draw a conclusion on which machine is better. First, binary machine number 1. I already designed the machine. Take note that 1 represents yes and 0 represents no. Now we will find the occurrence of each letter base and their machine of each letter base in this machine and compute the entropy using two methods. First, we will determine the number of bits by tracing up the path. For A, it is 1, 1, 1, and so it have 3 bits. For probability of having 3 bits is the formula for probability of 3 bits is 0, 1, 2, 5. Using the formula 2 raised to negative n, and n is equals to number of bits. So 2 raised to negative 3 bits equals to 0.125, same as the letters C, D, E, I, O, R, because they have 3 bits. So for letter B, so for letter C is equals to 1, 1, 0. For letter D is 1, 0, 0. For letter E is 1, 0, 1. And for letter I is equals to 0, 1, 1. The probabilities is also the same, 0.125. And for the letter M is 0.0625, and the bits is 0.0101, and n is equals, the bits of n is equals 0100, and the probabilities is equals to 0.0625, and the number of bits of O is equals to 001, and the probabilities is equals to 0.125, same as the A, C, D, E, and I. Same also on the R, 0.125, and the number of bits is equals to 000. Here we will use the probability method in determining the entropy, and for the and following this formula equals to H equals to 7 times 0.125 times 3 bits plus 2 times 0.0625 times 4 bits. H equals to 3.125. Using Hartley equation and Hartley function, H equals to 7 times 0.125 logarithm base 2 times 0.125 plus 2 times 0.0625 logarithm base 2 times 0.0625, and h is equals to 3.125. So they have the same value. So for binary machine number 2, same as the first machine, here we will also find the number of bits and get its probability using the same formula, 2 raised to negative n. So for A is equals to 1, 1, the number of bits, and its probability is 0.25. C is 0, 1, 0, 1, 1, 1 number of bits, and the probabilities is equals to 0.03125, and the number of bits of letter D is 1, 0, 1, 1, 0, and the probability is equals to 0.03125, and the number of bits of letter E is equals to 1, 0, 1, 0, and the probabilities is equals to 0.0625, and the number of bits of I is equals to 1, 0, 0, 0, and the probability is 0.0625, and the number of bits of M is equals to 1, 0, 0, 1, and the probability is equals to 0.0625, and the number of bits of N is equals to 0, 1, and the probability is equals to 0.25, and the number of bits of letter O is equals to 0.001, and the probability is equals to 0.125, and the number of bits of R is equals to 0, 0, 0, and the probability is 1 and is 0.125. And using the probability method, H is equals to 2 times 0.25 times 2 bits plus 2 times 0.125 times 3 bits plus 3 times 0.0625 times 4 bits plus 2 times 0.03125 times 5 bits equals to 2.8125. Using Hartley equation or Hartley function, H is equals to 2 times 0.25 log base 2 times 0.25 plus 2 times 0.125 log base 2 times 0.125 plus 3 times 0.0625 log base 2 times 0.0625 plus 2 times 0.03125 log base 2 times 0.3125, and equals to 2.8125. So summary: machine 1 and machine 2. The entropy number is of machine 1 is 3.125, and the entropy of the machine 2 is 2.8125, and to get the maximum entropy, we will use the formula H equals to log base 2 raised to M, and M is equals to number of resulting letters. Mine is 9, so log base 2 times 9 is equals to 3.16. 9925, and that is the maximum entropy, and the N is coding efficiency of machine 1 is 0.96986, and the code efficiency of machine 2 is 0.887. To get this, just divide the actual value, which is 3.125, and the maximum value, which is 3.169925, same as the machine number 2. Just divide the 2.8125 to the maximum entropy to get the 0.887. To compare the machine 1 machine 2, the machine 1 has the highest entropy, and machine 2 has the lowest entropy. Machine 1 has less predictable, and machine 2 is most predictable, and machine 1 is lower probability, machine 2 has higher probability, and machine 1 has most random, and machine 2 has less random. More information needed to be transmitted to get the desired outcome. The machine 2 has less information needed to be transmitted to get this desired outcome. Thank you.